My wife bought me this Orilux World War I officer's trench torch with Morse code key on one side and a light switch on the other. And it even came with an original light bulb, which I put in so I could show it to you. It's sort of a squashed pumpkin shape, and the element is laid horizontally instead of sticking up vertically. And it was wrapped in this deteriorating piece of tissue paper. The bulb was then stored in a hole in a block of wood, held within the lid of the case for the torch. Now the LEDs I'm using are 1 watt warm white LEDs, warm white giving a glow similar to an incandescent bulb, but much brighter for less power consumption. I bought this bag of 100 Epistar brand LEDs for less than $20 a couple of years ago. Because I'm only using 2 alkaline C batteries at putting out a little bit over 3 volts when new, these LEDs will put out very little heat. They'll be less than half their maximum brightness, but compared to the original incandescent bulb, they'll be still far, far brighter. Now, before panicking, this is the other light bulb that was already in the torch, and it is blown and doesn't work anymore. I'm going to crack off the glass, which is surprisingly strong. There we go. Now we use a pair of pliers to nibble off any bits of glass that are still sticking up around the edges. We cut a short length of heat shrink tubing and position it around the top of the bulb so that it covers over the sharp edges and will stop the original filament wires from touching it. So we heat the heat shrink tubing from behind. I heated it from the top first time I did this, and as it shrinks it just pulls itself off the bulb. So you start heating it from the base of the screw-in ferrule and then warm it up until it has nicely shrunk all around, as you can see here, keeping everything nicely insulated. Snip off the original broken element and gently bend over the 2 wires, 1 per side, and sand them so that they're nice and clean. In hindsight, I should have done this before I bent them over. Now, these wires have been bent over at the top to hold the original filament, which gives a slightly flatter area, a larger area to solder to. So I'm twisting each of the wires so that the flat area is lying face up. Now, using some metho, or as you might know it as denatured alcohol, wipe all of the surfaces to be soldered to make sure they're grease free, including the contacts on the 1 watt LED. Solder the upturned faces of the bulb wire and also the top surfaces of the LED contacts, as we will be bending them underneath. Also clean the little heatsink under the LED with some metho as well, get it really clean, and then get a small square of electrical tape and stick it down to it so that the 2 LED contacts have no chance of shorting out against it. Now we're going to carefully fold those contacts underneath the LED. Now we're checking the polarity of the power source, and you'll notice that the voltage is a bit under 2.8 volts, but the LED will be quite bright enough. And the center contact at the bottom is negative and the reflector around the side is positive. So the lower filament wire here is negative and the upper one will be positive. LEDs will only work in the correct orientation, and usually the positive will have a different mark to it, like a clipping out or something, so that you can solder in the correct polarity. Now, using the multimeter to check the circuit. Yes, it works, it works. I then decided it was worth protecting the contacts from the LED, so I put another piece of heat shrink tubing around that, and this also has the added benefit of strengthening it. The first one I made like this a while ago was fairly flimsy at the top, so this heat shrink tubing is supplying a lot of extra support. Now we have to make sure the LED is vertical in relation to the base in all directions. We turn it around and gently push it while the heat shrink tubing is still warm and soft, and it will cool down and firm up. Don't panic if in use you realize it is a little bit askew. You can just warm it up again and prod it around a little bit more. And a final circuit check. Yes, it still works. In order to protect the little conical aluminium reflector, I put some heat shrink tubing around this pair of flat nose pliers. And the initial twisting in you can do holding the LED itself, but once you get some tension going, I recommend angling the pliers so that you can get right down and screw on the base. And no light. Tighten it up a bit more, just in case. Nope, nothing. It would seem we have too much heat shrink tubing. So very carefully with a knife, watching your fingers and also the LED, trim some of the heat shrink off. Get rid of it. So we've reduced it to about half the length it was. And now we try again. And success! Now I do realise the LED is behaving differently to the original bulb and doesn't work very well off the conical reflector, but this torch has a bullseye lens, and that's a different matter altogether. You can see the centre of the LED filling up the lens and beautifully bright. It's an extremely directional torch, which is exactly the sort of thing you want when you're down in the trenches and wanting to signal to your friends but not your enemies. The torch comes with a beautifully fitted case, leather case, and both the torch and the case showed basically no signs of wear. The lid is shaped to cover most of the lens, and there's a little lightweight wooden button inside it, which is attached to a soft leather patch in the top of the lid, so that when you press on it, it activates the Morse code function. So even with reduced voltage, it's still extremely bright from square on, and nearly invisible from the side. The torch could be worn over your belt, and as you can see, these belt straps are unused. And it also came with provision for a shoulder strap, which was missing, so I made a matching strap for it. So that is my World War I Orilux Officer's Trench Torch with modified bulb.